Alright guys, welcome back. We're going to do 7.5, rationalize one-term numerators or denominators. So when you're asked a question, it'll specify to rationalize the numerator or denominator. Rationalize just means get the radical out of the specified place. So rationalize means get rid of the radical from either the numerator or the denominator. Okay, so we're going to start. The first three questions we're going to do are going to be rationalize the denominator. One term. So if I had something like the square root of 2 over the square root of 7. Well, this is just a single term. This isn't like the square root of 5 plus the square root of 2. This would be two terms, right? Like we just talked about. These are single terms. So if I want to get rid of the square root in this denominator, the best thing and the easiest thing to do is to simplify it first, which in this case it is, 7 is prime. And whatever I do to the bottom of this fraction, I have to do to the top. So remember that the square root of anything times itself is just that thing. If I'm trying to get rid of the square root of 7, the best thing to do would be to multiply it by the square root of 7. So on the top, I would get the square root of 14. And on the bottom, square root of 7 times the square root of 7 is just 7. I just rationalized this denominator. Or in other words, I got the square root out of the denominator. I didn't change the value of this expression because as long as we do the same thing to the top and the bottom, then we're good to go. So this is rationalizing the denominator of a single term. Let's do a couple more of these. I'll leave that one there. Let's do rationalize 6 over the cubed root of 9. Well, again, I want to rationalize the denominator, so I want to get rid of this cubed root of 9. I could think of this as 6 over the cubed root of 3 squared. Remember, if I want to be able to pull this out, I've got two 3's in here right now, but I need a third 3. So what I would have to multiply both the top and the bottom by would be the cubed root of 3. Why did I choose the cube root of 3? Because 3 times 3 times 3 is 27, or there would be 3 3's underneath that I could now pull out. So I'm going to multiply this by the cube root of 3, top and bottom. As long as I do the same thing to both the top and bottom, then this stays the same. So on top, I'm just going to have 6 cubed roots of 3, and on the bottom, I'm just going to have 3. Again, this cubed root of 27, 27 is a perfect cube. It breaks down into the 3 3's, and when you have 3 of them, then it can come out. So I got the radical out of the denominator. This is rationalize the denominator. So a couple questions here. Some people say, well, hey, couldn't I cancel this 3 with this 3? Well, we can't do that because this 3 is under this radical. That means that this 3 is to the 1/2 power, which is not the same, or sorry, the 1/3 power, which is not the same as 3 to the 1st power. But can I cancel this 6 with this 3? Well, I sure can, because anything that is related through multiplication is a factor, and we can cancel like factors top to bottom. So I'm going to factor a 3 out of here. That'll leave me with a 2, and when I factor a 3 out of here, that'll leave me with a 1. So that gives me 2 cubed roots of 3 over 1, but anything divided by 1 is just itself. So this would be rationalizing this denominator. All right, so let's look at one more of these. So this one's for you to practice. Rationalizing this single term denominator. So go ahead and pause this video and see if you can rationalize this denominator. All right, hopefully you took a minute. We're going to use the rule that the square root of a over the square root of b is the same thing as the square root of a over b. So I'm going to separate these out. And then I'm going to simplify. So with 50, I'm going to go back to this trying 2, 3, or 5 when I'm factoring. This factors to 2 and 25. Perfect, because 25 is a perfect square. So this would then be square root of 3x over 5 root 2. Now again, my goal here is to get rid of this radical in the denominator. I only need to get rid of the radical term. I don't need to get rid of this 5. The 5 can be there. So if I want to get rid of the square root of 2, then what I'm going to do is I'm going to multiply by the square root of 2, because the square root of anything times itself is just that thing. Whatever I do to the bottom of the fraction, I have to do to the top. So underneath here, I'm going to have the square root of 6x. And on the bottom, what do I have? Well, I have a 5 here already, but the square root of 2 times the square root of 2 is just 2. 5 times 2 is going to give me 10. Now, can I cancel a 2 out of this 6 and this 10? No, I can't, because this 6 is under radical and this 10 is not. So you can't cancel things that are under with things that are outside. So this is as simplified as we can get that. Again, we rationalize the denominator, which means I want to get the radical out of the denominator. Okay, so that is rationalizing the denominator. Well, what's rationalizing the numerator? It is the same thing, just want to get rid of it in the numerator. So this time we'll have the square root of 4x over 5, and I don't want a radical up top. So, and the square root of 4 I can do. This is actually 2 square root of x over 5 if I'm going to simplify it first, right? But I want to get rid of this radical in the numerator. So if I have this radical, I'm going to multiply it by itself. Only the square root of x. I don't need to multiply it by this 2. I'm not trying to get rid of the constant. I'm only trying to get rid of the radical. So if I multiply the top by the square root of x, then I have to multiply the bottom by the square root of x. That will leave me on top 2 times the square root of x squared, or 2 times x. On the bottom, I will have 5 times the square root of x, which is fine. So I will end up having 2x over 5 square roots of x. Now again, I just want to get that radical out of the numerator. So in this case, we are rationalizing numerators, not denominators. I can't cancel this x with this x because this x is underneath and this x is not, and 2 and 5 can't be simplified. So this is rationalizing this numerator. We're going to do 2 more of these, and hopefully you can practice yourself and get a few of these right. Next problem is going to be the cubed root of 5y squared over the cubed root of 4x. So here I just want to get this cubed root out of the numerator. Right now I have 1 5 and 2 y's, but if I want to get rid of the 5's, I need 2 more of them. 2 more 5's is going to give me 25. 5 times 5 is 25. And then I need 1 more y. So to get the cubed root, or to have 3 of these, I'm going to have 5 times 5 times 5, y times y times y. Okay, so that's what I need to multiply to get this radical out of the numerator. Whatever I do to the top, I've got to do to the bottom. When I multiply the top, I get the cubed root of 125y cubed. Again, 125 is a perfect cube. That's going to be a 5. And y cubed is also a perfect cube, and that's just going to be 5y. On the bottom, though, I'm going to have 4 times 25, which is going to give me 100, and then this x and this y. I can't simplify this any further. I mean, this factors out to like 10 times 10, but I need 3 factors to simplify anything. So my final answer here is going to be 5y over the cubed root of 100xy. Again, I can't cancel this y with this y because one is under a radical and one is not. So this here is rationalizing this numerator. I wanted to get the radical out of the numerator. This last one's going to be a little harder. See what we can do with this one. This is going to be the square root of 18x to the 4th, y to the 6th, all over 3z. Again, I'm rationalizing the numerator here. This has been given to me as all one, so I'm going to try to separate them out. But first I'm going to simplify this. I can simplify this 18 and 3 to 6. So I'm just going to erase this out of here and say this is a 6. Now I'm going to separate them out. And say, I want to get rid of this here in the numerator. Well, what would I have to do? Let's see, can we simplify this top? Well, this x to the 4th is a perfect square, so I can bring it out and it's x squared. This y to the 6th is also a perfect square. I can bring it out and it's y cubed. So all I have left under here is the square root of 6. And on the bottom I have the square root of z. Well, again, all I care about is getting the radical out of the numerator in this case. So if I want to get rid of this square root of 6, the best thing to do is to multiply it by the square root of 6. Whatever I do to the bottom, whatever I do to the top, I have to do to the bottom. So on top then, I have this x squared, y cubed. The square root of 6 times the square root of 6 is the square root of 36. But the square root of 36 is just 6. So I'm going to write that 6 out front. On the bottom, I have the square root of 6z. 6 times z is just this 6z here. So, again, can't cancel these 6's. I don't care if there's a radical in the denominator because my only goal here was to get rid of the radical in the numerator. So I just rationalized this one-term numerator. Now, again, it's one term because all of this is related through multiplication or division. It's not related through addition and subtraction. So this is how you rationalize one-term numerators and denominators, whichever one is specified.